On another note, how's your dog doing?
All right.
That's good.
We're on page 47 in our notes, and we're talking about parallel lines and proportional parts. So we're doing a mashup of what we had before. Now, before we do this warm-up, I just want to sketch something for you. Can you draw two lines that look somewhat parallel here? And then go ahead and put that transversal in there. Anybody remember that term? So we've got our parallel lines cut by a transversal. I'm telling you they're parallel, or maybe they're marked like this with arrows or triangles. Okay, so why am I bringing this up? We're talking about parallel lines today. Now, if you guys can remember, this angle is congruent to this angle. These are called corresponding angles. That means that this angle corresponds here. So top right, top left, they're corresponding angles. So they're congruent. Now we also know that vertical angles are congruent. So these are congruent. These are congruent. These are vertical angles. This angle would match up over here, and this angle would vertical with this. We have a whole other bunch of things in here, and I don't think it's doing a great job showing it. So let's make these in black here. Okay. So we've got corresponding angles in the same spots. We've got vertical angles. But the other thing we have are those alternate interior. Do you remember the alternate interior angles are the same? We have alternate exterior are the same. We also had, and this is what people forget, they were called same side interior or consecutive interior, and they're supplementary. They add up to 180. So these same side interior, they're not equal together, but the one I have in black, the one with two red lines, these add up to 180, okay? If this angle is congruent to this angle, then these also must add up to 180. We also have the same out here. These are exterior. So we have same side exterior angles, they add up to 180. So most of these relationships are alternate interior, alternate exterior, vertical angles corresponding, they're all congruent. But the same side interior, same side exterior, they're supplementary, they add up to 180. So I want to remind you of that because now we're getting into these parallel lines in triangles. So if you can just take a minute, and I'm just going to make this extended. You don't have to do it on your paper. But you see we have the parallel lines cut by this transversal. That means that this angle is equal to this angle. And on this side, we have another transversal, and that means that this angle is equal to this angle. And then they share point G. So you can see the big triangle has G, and the little triangle has G. And so we know these triangles are similar by angle, angle. Okay, so we know they're similar by angle, angle when we see those parallel lines. Now they're not asking about that. They're telling us they're similar, but they're asking us to find find information. So EH is 9, HG is 21, and just to have it, the whole thing is 30. All right, what else does it tell us? FL is 6, and it wants us to find LG. All right, we have a couple options here. I'm going to make LG X. Now, we can look at the full triangle to the little triangle, all right? And if we do that, it's going to be a little more work, or we can look at the parts. Anytime you have parallel lines here, we can break up the parts, and that's what we're going to focus on today. But how we would have done this before is we would have said 21, the little side, or the side of the little triangle, goes with 30, the side of the big triangle. And then we would have said equals X, but it wouldn't be over 6, it'd be over X plus 6. So this is what we would have done before. So small triangle over big, small triangle over the big. And that's what we talked about, not missing that. And then we would cross multiply. So we would have 21 times X plus 6 equals 30 times X. All right, well, that's 21X plus, I think it should be 126. Anybody? All right, plus 126 equals 30X. Okay, so I'm going to subtract my 21X. I'm a little out of room. I have 126 equals 9X. Divide by 9. What's X equal? I have 14. All right, and that's exactly what I wanted. I wanted the length of LG. It is 14 units. Okay, we're going to be able to change that up. We're going to use a theorem to find this without the extra. So we're still going to do a proportion, but what we're going to do is whenever you have a triangle cut with parallel lines like this, you have that this piece divided by the piece over here is proportional to this piece over this piece. So we're not looking at the full triangle, we can look at the parts, but we have to have the parallel lines. And we have to be looking at the sides. If we're focusing on this length and this length, we'd have to use the whole length. All right, so let's get into it. If a line is parallel to one side of a triangle, so see we have this line is parallel to this side of the triangle. That's what they mean. So we'll talk about BD is parallel to AE. All right, and it intersects the other two in two distinct points. So it actually does touch each side of the triangle. It's not just in the middle. Then it separates into segments of proportional lengths. Now, it's not telling me that this segment is equal to this segment. It doesn't tell me that this side is equal to this side. It just tells me that the proportion of CB over the whole side CA is equal to CD over CE, or BD, this side, over AE. So we can look at those proportions. So what can we talk about? Well, first of all, these are corresponding sides of the similar triangles. So I want to make sure you have that. You have to match up the sides. So corresponding sides of similar triangles. So we're still using that idea. Now, what allows me to conclude the triangles are similar? It's the parallel lines, okay? Parallel lines create, oh, you can't see that. Parallel lines create congruent corresponding angles. Everything's got to be corresponding. I'm not doing well with this. All right. And we use the angle similarity statement. All right, so parallel lines create corresponding angles that are congruent, and we know they're similar by angle. All right, so when you're done with that, flip it over. Maybe. All right, so let's look at this guy. Take another look at that warm-up problem. All right, so let's label. We know they're similar. We've got our parallel lines. EH is 9, HG is 21, FL is 6. We want to find that. Rather than doing little triangle to big triangle, we can do part to part equals part to part. And that makes it a little less work. Now, I can only do that if I'm doing these segment sides cut by that parallel line. I could not do that if I was using the base of this, because this would be the whole length. So part to part equals part to part. We cross multiply. I get 9x equals 126. Divide by 9, and there's that 14 again. So we cut out an extra step. Okay? So a little bit quicker there. That is all that is. So let's use that idea to do these proportions. We're not doing much new, but we're able to use these cut segments. So first thing, they are telling us these are the parallel lines. By having these parallel, this angle matches and this angle matches. So by angle, this little triangle and the big triangle are congruent. Now, if they're congruent, we know the lines are parallel. Sorry. If the angles are congruent, we know they're similar triangles, so we know the lines are parallel. It goes both ways. Please label everything. So when we look at your work, we want to see that these are labeled. Make sure you're looking at the whole thing or the pieces, and then UT is 12. So we're trying to find the US here. So I'm going to go with x over 3 equals 12 over 8. So you do have to pay attention to your setup. And so I get 8x equals 36. Divide both sides by 8. I don't get a nice integer, but I get 4.5, and that's not too bad. That's it. Okay? But I have to know either I have similar triangles or I have to know these lines are parallel. Knowing these lines are parallel, see how they told me that? Now I have that information. So go ahead and take a minute And I want you to think about labeling example 3. It's a little bit different because they don't give you all of the information. So it says DG is half of GF. All right, I'm going to come back to that. DH is 18. It tells me that HE is 36. It's important that they tell you right here, determining if the lines are parallel. They're not actually telling me these lines are parallel, okay? So it says that DG is half of GF. So I don't know what GF is. I'm going to call it X. I'm going to call this a half of X. That's the key. So in order to state what DG is, it's based on GF, so we'll call that X. All right, well, we're trying to prove if the lines are parallel or not. Now, if the lines are parallel, then these would be proportionate. So 1/2 X over 18 would equal X over 36. Now, I'm thinking you guys can see it because 18 is half of 36. So this would be proportional. We're just going to prove it. So we would take 1/2 X times 36, which is 18X, equals 18X. And do you see how my cross products, I'm not solving for X. See how my cross products are equal? If my cross products are equal, then the proportion is true. And if the proportion is true, then I can say that these lines are parallel. So is GH parallel to FE? Yes. Okay, so yes, corresponding sides are proportional. Corresponding sides are proportional. And we're talking about the length of the sides. You guys need to start yelling at me when I'm off the screen. So, yep, they are parallel. Corresponding sides are proportional. So we had to prove it. And it's proportional because we get a true proportion. All right, so we move on. So now the converse, I like to think about as like the flip side. We can go backwards to determine if the lines are parallel. That's what we're talking about now. So if a line intersects two sides of a triangle and it separates the sides into corresponding segments of proportional length, then the line is parallel. So if you can go back over here, it said if a line is parallel to one side of the triangle. So if we are told parallel lines, then we know it makes them cut into proportional lengths. Okay. Now we're saying if the line intersects two sides of a triangle and they're proportional, then we know the lines are parallel. So we're flipping it. Okay, so look at example 4. They're giving you the big triangle, HKM, and it says HM is 15. Okay, so that's the whole side. Be careful with that. HN is 10. HJ is 2 times JK. Okay, I don't want to write 2JK. I'm going to call JK X. Oops. So don't put the 2 there. Well, I'm going to put the 2 there. So JK itself is equal to X. So 2X is HJ. So that would be 2X. And JK would be X. Okay, now that doesn't look like it's drawn to scale at all, guys. And I say that because this is twice this length. It doesn't look like that, but that's what it's saying. Okay. And if this is 10 and the whole thing's 15, wouldn't this piece be 5? Okay, so I'm going to use that. Instead of using the 15, if that's 10, that's 5. And here's what I'm going to do. 5 over X should be equal to 10 over 2X. So I'm using this as like a divider. Okay, and I'm saying this segment over this segment should be equal to this over this. Now, I know that this segment is longer than this one. And I know that 5 is not the same as this length, but they're proportionate. So then I cross multiply. That would be 5 times 2x is 10x. X times 10 is 10x. Do you see that I have a true proportion? So are the lines parallel? Yes. NJ is parallel to MK. Why are they parallel? Why are they parallel? proportionate sides are congruent. All right, congruent, corresponding sides. Side proportions. I guess I should say that. A little bit of a struggle. Okay. I tripped myself up on the wording there. All right, now there's two more ideas that come from the theorem, so don't be overwhelmed by this. Okay. One, if three or more parallel lines intersect to make transversals, then they cut off the transversals proportionally. All right, so guys, we were working with this. A triangle, see the triangle? See the little triangle and then the full size triangle ACF? We were working with that, no big deal. We were having the little triangle, and we've been doing that, and the big triangle. So if you can focus on these two, that's what we've been doing. Now they're just showing the lines extended more, but it looks crazy. Now they're bringing in a third parallel line. So it's almost like we have three. You see the three triangles here? So whether I look at the red to the blue or the red to the green or the blue to the green, all of these triangles are similar, okay? But they also have all proportionate sides. So no matter how I cut this, AB right here over AE is the same as AD, the whole green triangle, over AG. BC, the little segment here, over EF is the same as the little segment CD over FG. So we can look at these as full triangles, or we can look at them as the cut segments, because anytime you have these parallel lines cutting through, you have similar triangles because all three of these correspond. So all three angles here, here, and here, they're all corresponding. Okay, all three triangles also share angle A. But that also means that these cut them into proportionate segments that are proportionate with the opposite side. All right, so let's use that to do a little bit more here. So that's what I'm saying. Don't get overwhelmed here, okay? Now, if three or more lines cut off congruent segments on one transversal, then the cut off congruent segments are on every transversal. All right, so there's not much to say here. They're just showing if all of three of these are parallel, boom, 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 then, and BC right here, BC, let me find BC. BC is congruent to CD. If this cuts it in half, then that means that EF, so if this is congruent to this, that means EF, segment EF is congruent to segment FG. Now, we weren't talking about congruence before. We were just talking about proportion. But if these cut and make these two congruent, then these are also congruent. Now, these are going to be longer. They're more of a diagonal, so they're stretched more. But these are going to be congruent to each other. Not across here. Proportional across here, congruent pieces. Okay, now, some other examples based on this. So we're given this figure, okay? Thank you. And we're not told anything about the figure other than the lengths of the sides. But mark this. It doesn't even matter that it doesn't look the same. They're saying that AD is the same as DB. And we can see that AE is the same as EC. Okay, so what's true? Guys, if these are proportionate, right? If you did this, 3 over 4 equals 3 over 4. So I can say that DE is parallel to BC. Yes. It asks which one is false, by the way. So that is true. D is a midpoint of AB. Well, by definition, a midpoint, absolutely, because these two pieces are equal. So that is true. Triangle ABC. Okay, let me find triangle ABC, the big triangle. Triangle ABC is similar to triangle ADE, which is little triangle. Well, that's true also, because if these are congruent, we've determined that these lines must be parallel, then these angles are congruent. So that would prove this by angle, angle. And I wish these had little triangle symbols there. And it says ABC, okay, triangle ABC, well, no, the triangle ABC is not congruent to the little triangle. They're similar, but not congruent. So this one is false. Okay? So a lot of facts you can know, but you can't just make things up. All right, I think we have one page left. So I want you to go ahead and take a minute, look at what you know. You can't make anything up. It is telling you to find X, so PQ is parallel to BC. So guys, if PQ was parallel to BC, if PQ was, it's not, it's telling us make it happen. If these are parallel, then these are proportionate, right? So find the value of X so they're parallel. If they're proportionate, they're parallel. So you would do, I'll start you. You would do 3 over 4 is going to equal X plus 0.25 over 3. All right, so take a second and do that cross multiplication. So when I cross multiply, I'm going to have 3 times 3 equals 4 times X plus 0.25. So that'd be 9 equals, and then we're going to distribute this to be 4x plus 1. And then I'm going to solve, subtract 1. 8 equals 4x. Divide both sides by 4. And so x is 2. So if x is 2, then that makes these sides proportionate, and that means they would be parallel. So by x being 2, we have parallel lines. Okay, now the next one can look a little overwhelming, and you have 2 variables, so you have to calm down. I can't do a proportion on this. Yes, all 3 are parallel. And can you picture this extending down to make that triangle? But we're not worried about the tip of the triangle. We're using what's in here. Now, with these lines being parallel, this divided by this should equal this piece divided by this. The problem with that is I have 2 variables. So there's more information. What other information do you see? Like normally I would jump in and do my proportion just like we did here. The problem is it's not going to be any good to have proportions with 2 variables in it. Do you see any other markings on the triangle that would help us? Well, I do. Don't they have these little tick marks here? Doesn't that mean that 3x minus 4 is equal to 6 minus 2x? So we're going back real basic. That has nothing to do with anything new. That just has to do with these are marked congruent, so we set them equal. All right, I'm going to add 2x. And so I get 5x minus 4 equals 6. Then I'm going to add the 4. So 5x equals 10. X is 2. Okay, so how does that get me anywhere? I got x. There's a couple options. You can make life harder. You could take the x and put it in. It just said find x. But if we put it in here, that'd be 6 minus 4. The length of that is actually 2. And then 6 minus 4, the length is 2. So we could do proportion where we do 2 over this equals 2 over that. But guys, the rule was if these 2 sides are equal, then guess what? These 2 sides are equal because of the parallel lines. So if these are equal, they would have the same proportion. So rather than having to do a whole mess, I can literally take the 5/3 y plus 1 and say it must be equal to 3y. So I had to transfer that information. Okay, now I know it has a 5/3 y, and that's going to bother you, but you're going to subtract it. You have a calculator, so you're welcome to use that. Just to show you how to do fractions again, just in case you're interested. Do you remember that you need a common denominator? So again, you could just type in the calculator 3 minus 5/3. I guess I'll show you that first. I'm just going to type in the calculator 3 minus 5 fraction 3, and I get 1 1/3. Okay, 1 1/3 y. Or if you don't like that mixed number, you could hit second and then your mixed number to improper key, and I get 4/3. Or, you know how to change your numbers. 1 times 3 is 3, plus 1 is 4/3. Now, we're not done solving for y, but I want to remind you, if I'm subtracting by hand, I need to get a common denominator. So that'd be 9y over 3 minus 5 over 3. Keep the common denominator, and then 9 minus 5 is 4/3, attach the y. Now I'm not done yet. It's 4/3 times y. And typically we get rid of multiplication with division. So I have a calculator. I can throw that in the calculator. 1 divided by 4/3, and I get 3/4. Okay, so why do I get 3/4? Well, again, if I'm not using a calculator, instead of taking 1 divided by 4/3, I would take 1/1 times the reciprocal. So instead of dividing by a fraction, I would multiply by 3/4 to cancel it, and that is why I get 3/4. So again, you can just use your calculator, but I wanted to remind you how to do that math by hand. And that is it.